Introducing PhotoModeler's SmartMatch by EOS Systems. PhotoModeler's SmartMatch technology provides automation for everyday photographs, creates 3D points, and determines the camera position and orientation with the push of a button. I will demonstrate using SmartMatch and some examples of what you can do with the results. I'll start a new automatic project, pick the Smart Points option, then load 4 photographs of our building facade. There are no targets or any special setup of these photos other than to keep the angles low between the photographs. And then press the Run button, move the progress out of the way, and we can watch in real time the SmartMatch processing of these 4 photographs. The detection, matching, and orientation is now complete. We can open up the photographs and take a look at the smart points that have been placed automatically on the photographs. And then the 3D viewer, with smart points turned on and camera stations, so we can see the automatic orientation that has been done, and again without any targets, our top-down view showing the points. Since this is a fully oriented project, I can now do some other processes. In this case, I will do some measurement. Close the 3D viewer, open up a couple of the photographs, and I'll turn off my smart points. And then I will use the line tool and the Alt Zoom to outline this upper window. Marking each corner precisely using the zoom in. Selecting all the points, and then going into referencing mode. I can now use the reference helper lines and the zoom in the other photograph to help position. Since these photographs have been oriented automatically, the helper line tells us that we have a good position. I have points and lines in the 3D viewer, closing the photographs, and quickly you can see the window outline in the smart points. And then to do a measurement, we need to set up a scale. I'll use the scale wizard in meters, set the width of the window to 1.1 meters, select the bottom of the window as my scale point, and finish. The project is now scaled to the accurate real world. Using the dimensions on photographs, I now have a result that is useful. I have a small statue that has been smart matched. You can see the photographs of the marks, and in the 3D viewer you can see the results of the oriented camera station and the 3D smart points. Dense surface modeling has been run on this resulting project, and this is the result of the dense point scan, showing how useful it is to have SmartMatch set up the project for easy DSM modeling. SmartMatch makes this project much easier because targets were not needed, and so the photography was quite quick. Imagine this were a 100-foot tall Buddha statue where placing targets would not be practical. Here I will show a full surround photo set. In this case, a large rock that has been converted into a community drinking fountain. I have 27 photos taken in the round with small steps in between. I will start the SmartMatch processing on these 27 photographs. We'll jump to the end take a quick review of what's happened with all the marking and matching and orientation. Then we'll look at the 3D viewer and the camera stations and the points that have been solved. You can see the photo stations in the round surrounding the rock that have all been done automatically. Because of the density of the points on this project, we can do a unique thing and convert the smart points into a point mesh, triangulate that, and produce a surface model. So we'll execute the triangulation and hole filling on those points, shown in real time. Turn off the smart points to see just the resulting surface model. So we have a triangulated surface mesh created just from the smart points. And lastly, we'll show the textured result. The texture is coming from the original photographs that SmartMatch was run on. All of these SmartMatch processes were run on this computer. A more up-to-date computer would give you even faster results. Lastly, we show a geology application where we use SmartMatch to quickly orient photographs without any laborious manual marking and without targets. Here we have the smart points solved and the camera stations shown. I then idealized the photographs and executed a full extents DSM on one pair, and I get this result. You can see I've used DSM to densify the smart points so that we can do surfacing, measurement, contours, etc. at higher accuracy. For SmartMatch to function well, there are three main requirements. The photos should be taken with good overlap and no gaps. The photos should be taken close to each other with angles between the photos being small. And the subject material should have a random pattern or texture, such as a brick, stone buildings, rock walls, stockpiles, quarries, digs, statues, etc. Please contact EOS Systems if you have questions about the compatibility with your projects. You can see that the SmartMatch technology of PhotoModeler 2010 is an amazing advancement and a great addition to the world's premier image-based modeling and close-range photogrammetry tool. Visit the PhotoModeler website to get further information on the PhotoModeler products and the new SmartMatch.